There's only 4 problems.
Yes, the assignment on this one will be short. So 2.4 notes. This we are going to do elimination. So this is why I was very strict on how you showed your work in Unit 3. It's very important that we know how to accurately show work when we're solving system using substitution and elimination, because now we're going to be doing it in 3 variables. These get to be very lengthy problems. Sometimes they will take up a whole page or about a half a page. So yes, the assignment looks like it's only 4 problems, but you'll notice you'll have a lot of work on, or 3 problems, only 3, okay? But you'll notice for those 3 problems, you will have to show a lot of work, okay? And so we're gonna do our best on our notes to show how to keep your work organized, how to show your work completely, because it's very hard to find a final solution. And because of that, I will make sure to give you points along the way. Does that make sense? But if you're not showing your work to where I can follow it, I won't be able to give you those points along the way. And each of these problems are usually worth about 10 points. Okay, so if you don't have your final solution, but you've shown a lot of your work along the way, you can earn 5 to 7 points out of those 10 points. That's quite a few points when you're looking at an overall quiz, okay? If I can't follow your work, then you get 0 out of 10, and that's a lot of points lost because you couldn't show your work in a nice, organized fashion. Does that make sense? Okay. You should also know if your solution is correct in the end, because what defines a solution? What makes it a solution to a system? You guys know this from Unit 3. If it works in both equations, if you plug it into both equations and it's true, it's a solution. So a solution is still going to be the exact same thing. We just have to plug it into all 3 equations. Does that make sense? Okay, so our goal today, when we're doing this one, is, I got to get my props out because I have some demos to show you also. Okay, it's to solve systems in 3 variables by elimination. On Wednesday, we'll focus on substitution. And then I used to make you guys draw these, but I was nice and copied the pictures on here for you. There are still inconsistent, independent, and dependent systems. When I am asking you to solve, there will always be one solution, okay? So if I'm asking you to solve and you get no solution, you probably did something wrong, okay? If I'm going to have you solve, there will be a solution for you to find. But I want you to know that it is possible that there are no solutions when you're dealing with systems in 3 variables. When we're dealing with this, 3 equations, okay, each of those equations are a plane. If there were no solution, then that means that all 3 planes don't intersect at one point. So for example, if you had three planes that are all parallel. Let me see if I can demo this for you. Okay, so like this. Let me put them on here. Like this. Kind of can see those. Maybe I did a different angle. I can't do that on here. It's too complicated. The angle is so weird. I didn't need another hand. There we go. So if we had 3 parallel planes like this, the planes would never intersect. And if that was the case, there would be no solution. Okay? If 2 of the planes were parallel and the third one was going through them, there would still never be an intersection where all 3 planes meet because these 2 planes still never meet if 2 of them are parallel. Do you see that? Okay. If 2 of them meet at one spot and another one meets at another spot, that's also not going to work because not all three planes are going to meet at the same time. So that would also create no solution. So that's like this one here, which has like a little triangle in between. When there's one solution, that means all three planes intersect at one point. You can see the point that is highlighted there where all three planes intersect at a common point. Okay. If they have infinite number of solutions, it's something like this, like a fan almost. There you go. Where they meet in a line, but all three planes meet in that line. So there's an infinite number of solutions along that line that represents the plane. Or if the planes were the same, if they overlapped. Okay? Kind of like our dependent systems, if you have two lines that are the same. That can also happen. I will not make you solve systems that look like this, but I want you to know that they do exist. Okie doke. All right, so solving a system using elimination. The first thing that we're going to do is we're going to choose a variable to eliminate. Now before you only had you can eliminate x or you can eliminate y. Now we're going to have you can eliminate x, you can eliminate y, you can eliminate z. Okay, so you have to choose which variable you're going to eliminate. Okay? The next step is going to be to pair two equations. And eliminate the variable. Okay, you chose it. You chose which one you want to eliminate. So you're going to, it's really hard to read, sorry. Pair two equations and eliminate the variable. I'm going to write times 2 because you're going to actually do that twice. Okay, once you've done it twice, you're going to have a system of two equations. So you're going to write the system of two equations into variables. Okay. When you do that, you get to solve using any method. That's review. You guys know how to solve a system in two variables. So when you get it to that point, you get to solve it any way you want. Now you're probably like, these steps make no sense to me. They probably don't right now because we're just writing them down so you have them to refer back to. Once we've practiced it, then they'll make more sense. Does that make sense? Okay, that was a lot of sense. All right, so step 4 is to, once you've solved that system of two equations, you're gonna know two variables. You'll use the two known variables and plug into an original equation to find the last unknown. And the last step is to check your solution. So I'll give you a minute to finish copying that down and then we'll move on. All right, now that we have those steps down, we are going to just review how to solve a system using elimination. So this is review. We're given two equations. We're working in two variables. How would I solve this? First choose, do you want to eliminate x or do you want to eliminate y? Okay, let's eliminate x. Okay, when we go to eliminate x, you always want to write these as a pair. What do you want to do to the first one? You want to leave it alone or you want to multiply by something? What do you want to do? Multiply by what? -3? Is that what you guys said? Is that okay? Okay, so what I get when I do that, I get -6x plus 9y equals +33. I'm going to make sure to rewrite that. And I'm also, whatever I do to the second one, I'm going to make sure I write it right underneath because I'm always going to line them up, okay? Do one step at a time, and I'm going to keep them lined up. What am I going to multiply this one by? Or am I going to leave it alone? Times 2. So I'll have 6x plus 8y equals 18. I always write them as a pair. Am I ready to eliminate? Yup. So my x's do eliminate because -6x and 6x make 0. Okay. How many y's do I have? 17y equals 51. Okay. What does y then have to be? Is it 3? All right. Am I done now that I have y? No, what do I have to do? Plug it back into one of the originals. So I'm going to take that y. You want to plug it into the first one or the second one? First one? Okay, we can do that. 2x minus 3 times the y was 3 equals -11. You're just going to solve for x now. 2x minus 9 equals -11. You're going to have to add 9 on both sides. 2x equals -2. Divide by 2 on both sides. X equals -1. Am I done? I couldn't even see what I was writing. What do I need to do? Write it as a point. So my answer is actually what? -1 comma 3. That's my solution. Solution or answer is -1 comma 3. That's my answer. Now, I should also probably check that. When you check that, you're going to plug everything back in. My 2 times the x was -1, minus 3 times y was 3. Should be -11. Okay, cover up this side, plug that into your calculator. What do you get? Well, I hope I get -11 because that's what the other side is. 2 times, -1 minus 3 times 3. I get -11 on the left. Equals -11 on the right, so it works for that equation. Plug it into the next equation too. 3 times x was supposed to be -1, plus 4 times y is supposed to be 3, equals 9. Cover up the right, let's plug in the left. 3 times -1, plus 4 times 3, I should get 9, equals, that's 9. It works. It worked in both. So that solution is, I've confirmed my answer. And it's the correct answer. So far, so good? Okay, that's review. Give me a 1 through 5. I'm good with the review stuff. I got elimination down. Coolio. I'm waiting for your 1 through 5. Yeah. I didn't see yours. Okay. All right, so let's go to the back side. All right, step 1 says to choose a variable to eliminate. Now, I set this one up for you, okay, and I wrote all the steps in. Your assignment doesn't necessarily give you these steps, but you still have to do these steps because if you tell me your variable to eliminate, there's your first easiest point ever. Okay? Does that make sense? What variable do you want to eliminate? Do you want to eliminate x, y, or z here? Beauty is you get to choose. Want to do y? Okay. So I'm going to eliminate y. All right. Then I'm going to make a combination of two equations. It does not matter the combination, but maybe I'll combine A with B. Maybe I'll combine B with C, and I'm going to label what I'm combining there. Okay, I'm going to do this twice because I remember it said times 2. So here's A. I'm always going to write them together and I'm going to label them. When you write your Z's, if you put a line through it, sometimes it helps you because people get Z's confused with 2's often. So be very careful. Make sure there's something different between your 2's and your Z's. My B is x plus y plus 3z equals -3. Should I multiply the first one or the second one or both? You don't have to. I don't have to. Why? I'm trying to eliminate a y, and I already have a negative y and a positive y. Negative y and positive y already eliminate to nothing. Okay, what's x plus x? 2x. Z plus 3z. 4z equals -1 and -3. -4. Don't do anything else. You're done. So far, so good? Okay. What we did was we created an equation in only 2 variables. So what I'm going to do is I'm going to write the system of 2 equations in 2 variables, which I did in blue. So that answer, what I got right here, becomes part of my system of 2 equations. That's one of my equations. And then I'm going to come over and I'm going to do this, because it said times 2, I'm going to do it with combination of B and C. What's the other combination you could have done? A and C. Anyone see why B and C might be nicer to use than A and C? I won't have to multiply. B and C also will eliminate the y right away. So what I'm going to do is I'm going to write out B. I'm going to write out C. B is x plus y plus 3z equals -3. C is 2x minus y plus 2z equals 0. And since the y's already have opposite coefficients, I am good to just add them because my y's will eliminate. X and 2x is what? 3x. 3x and 2x is 5, and that's what I meant, 3z and 2z. It's 5z equals, what's -3 and 0? -3. And that's your second equation that we have for our system in 2 variables. Now, our system is only in 2 variables. What 2 variables is my system in? X and Z. It's no different than if this system was in X and Y. Okay? You guys already know the steps to take to solve the system. Whether you want to do elimination or substitution from this point on is totally up to you, because that's all review. So you can solve the system in 2 variables. What way do you want to do? Substitution or elimination? I would recommend elimination here because your variables are already lined up. Okay? Also, there's probably only one variable there that you could solve for and not get really nasty numbers. So I would probably recommend to do elimination. So I'm going to label these now 1 and 2. What should you multiply 1 by? What should you multiply 2 by? 1 by -3. Okay, so -3 times the 1 equation is going to turn into -6x minus 12z equals +12. What are we going to do to equation 2? Multiply by 2. So 2 times the equation 2 will turn into 6x plus 10z equals negative 6. I'm good to add those now because I have opposite numbers or coefficients in front of the x's. So by doing that, you chose to eliminate the x here now. So our x's now go away. I have negative 2z equals 6. Okay. My best recommendation is when you are doing this, you double check every single step before moving on, because it gets very frustrating when you get to the end and can't find your error. Divide both sides by negative 2. Z is negative 3. I know that my solution is a point, but it is an ordered triple. I did find the z, so I'm going to put that in the z spot as negative 3. How can I find any of the other variables? Plug them in. Where should I plug in z is negative 3 to? You have to plug it into either 1 or 2, the ones that only have x or z in it. You can't plug them back in yet to the original because you would still be missing x and y, and then we wouldn't solve for it. So we have to plug it into one of these, just like we would if we were solving that system. So 2 times x, we don't know. If you want to plug it into the first one, you can plug it into the second one too, it doesn't matter. Plus 4 times z is negative 3 equals negative 4. And we're going to have to solve this. 2x minus 12 equals negative 4. Add 12 on both sides. Divide by 2 on both sides. You should get that x is 4. So I'm also going to fill that into my solution in the x spot. What else? I have x and I have z, but how am I going to find y? You have to plug it back into either a, b, or c. Okay? So, which one do you want to plug it into, a, b, or c? A? Okay, sure. So A says x is 4 minus y we don't know plus z is negative 3 equals negative 1. So there it is. I plugged it in. Now I'm going to get y by itself. 4 and negative 3 is 1 minus y equals negative 1. Biggest thing I see people keep doing is they're subtracting 1 here and they're telling me that that's y is negative 2 and they're saying it's done. When I subtract 1 on both sides, what is wrong with what I just got? There has to still be that negative sign in front of y because it was subtracting y. Okay, a lot of people are losing a negative sign there. Okay, and then what? Divide by negative 1 on both sides, so y is 2, and I can fill that in then. All right, time to check. So, when I have to check, I'm going to plug it into A. X is 4 minus y is 2 plus z is negative 3 equals negative 1. Cover up the right side. I'm going to plug in the left side to my calculator. 4 minus 2 plus negative 3. That's supposed to be negative 1 equals negative 1. Cool, it works. I'm going to try it with B. In B, I have x is 4 plus y is 2 plus 3 times z is negative 3. I should get negative 3. 4 plus 2 plus 3 times negative 3. I should get negative 3 equals negative 3. Cool. That also works in B. I still have one left to check. C. In C, I have 2 times x is 4 minus y is 2 plus 2 times z is negative 3 is supposed to be 0. I'm going to plug this in. 2 times 4 minus 2 plus 2 times negative 3. I get 0 equals 0. That also works. So is that a solution? Yes, it is, because it worked for all three of my original equations, A, B, and C. That's how you're going to do elimination for a system in 3 variables. Yes, go ahead.
Do we have to plug in every single system to check it?
If you read the directions, it says check your answer. So yes, you need to show me that you plugged in your solution to all 3 and you got them all 3 correct. Which means that if you get something wrong, you should probably go back from the beginning and try to find your error so you can fix it to have the correct solution. Okay? And you guys still have close to a half hour, so you should be able to get the majority of this done and check in both assignments before you leave.